Trina here, and today I'm going to show you how to solve for x if x is in the exponent. So let's look at a generic example. What if we have some b to the power of x equals to a? Well, how do we solve for x? We're used to seeing examples where you'd have x plus b equals to a like this. And here we just use the typical order of operations to solve for x. We would subtract b to the other side, so then x equals to a minus b. But what do we do in this case when x is in the exponent? Let me show you. This is where we get to introduce a new concept called logs. It's very exciting. So if we were to have an example where we have 2 to the power of x equals to 9. You might go through your head and try some examples. You might check 2 to the power 1, okay, that equals to 2. 2 to the power of 2, that equals to 4. If we keep going, we see that 2 to the power of 3 equals to 8, not quite 9. But then if we do 2 to the power of 4, we get 16. Our 9 exists somewhere between 2 to the power of 3 and 2 to the power of 4. But how can we find our exact value of x without guessing? Stay tuned. This is what we're doing next. This is where we apply the log. So just like any other mathematical equation, if you apply a mathematical expression to one side, you must apply the same to the other side in order for it to be mathematically consistent and correct. So what we're going to do is we're going to add a log or apply a log to both sides of the equation. So let's take a look. So we've got 2 to the x equals to 9. We're going to now put a log in front of both sides of our equation. So this is still mathematically equivalent. Log rules allows us to do something really cool. It allows us to take whatever exponent we have and put it as a coefficient on the other side. So now it is taking x away from being an exponent. And that's something that we're a bit more comfortable with. So now we've got x log 2 equals to log 9. And now we can apply just generic algebra in order to solve for x. So since there's a multiplication between this x and log, that means that we have to divide this side by log 2 and divide this side by log 2. Now we end up with x equals to log 9 divided by log 2. And I'm going to show you one more cool trick. This is called the change of base formula. So we can take log 9 divided by log 2 and change it into log 9 base 2. Because these two previous logs, if it's not specified, it means that they have a base of 10. So here they have the same base, and we can now apply change of base formula that states that if you have, let's look at this formula, let's say log A divided by log B, we can use change of base and get log base B A, where A is our argument. And look at that. We solved for x and got an exact value for a problem that seemed really difficult, but now we can see that there's an easy and quick way to solve it. If you found this video interesting, drop a like and any comments below. I'd be happy to go over more examples and help you on your math journey. Subscribe for more, and I'll see you next time.